Hi everyone. I just wanted to talk about data analysis today. So there's two main things to consider with data analysis. One, where is the center of the data? Two, how spread out is it? All right. So first, finding the center of the data. All of you are probably familiar with the term average. Average is also called mean. This is when we take all the values, we add them all up, then we divide by however many numbers we added together, right? There's also the median. The median is where you take all of your data, you put it from least to greatest, and then you find the middle by crossing off numbers, circle the middle, right? And that is your median. If there's two numbers in the middle, you take them, you add them together, and divide by 2. That will become your median. The last way to measure the middle is mode. Mode means most. Whatever value occurs most, all right? And you can also have no mode. Say your data set is 1, 2, 3, 4, 5, 6. None of them repeat, so there would be no mode. Say your data set was 1, 2, 2, 4, 4. Well, then 2 and 4 would be your mode because they both occur twice. So you can also have more than one mode. If you have more than one mode, you would separate them using a comma, okay? So for you visual people, I'm going to write those things down. So mean, which also means the average. Then we have median, and we have mode. Those are the three main concepts to measure the center of data. Now, you can calculate these three things right in Excel as well, which think about these processes if you had a data set of, say, 50, 100, 1,000 people. The likelihood that you make a mistake in those calculations by hand or using a calculator is very high. So Excel kind of takes that away and makes it more likely that you're accurate. So to do that, I'm going to show you two different ways. So the first thing I'm going to do is click in the box next to mean/average because that's what we're going to calculate first. Now, one way that you could do this is you could go up to formulas, then click more functions, then go down to statistical, and you'll find average right there. So click that, and you'll get this box that pops up. And it just wants you to highlight your numbers, highlight your data. So I'm highlighting my class's grades. On the left, you can see class 1 grades. That is a 201 class. That is this semester. All right. Well, I guess if you're seeing this in the future semester, this is April 2019. But regardless, click OK, and you get your average, 71. Passing. It's week 13, so they're about to finish strong anyways. Now, same thing for median. You can go up here. You can do more functions, statistical. Now find median. So scroll down. There's the median. Highlight your data. Click OK. 79. If I'm going too fast, remember that this is a video and you can pause me. And then rewind and rewatch. I would highly recommend doing this on your own to learn it rather than just watching me. Lastly, your mode. So this one's a little bit different because you can have more than one mode. So what you want to do is you want to highlight multiple boxes like I have here. Then type equals, oh, sorry, I jumped ahead of myself. Go to more functions, statistical. Find mode multi is what we're looking for. This one right here. Click that. Highlight your data set. Click enter. It says NA. What NA means is there's no mode. It didn't spit you back a 0 because that would mean that 0 is the mode. Thankfully it is not. So, no mode here. Now, let me put these, sorry, I'm OCD. We gotta put them in the middle. They're bothering me. All right, now let's go to class 2. Let's repeat this. So I'm gonna copy these and go over to class 2. right? Mean, median, mode. Now I'm going to show you a different way to do this. I do this a little bit different of a way. If you click the equals button, it turns Excel into a calculator. So I can do equals and then type in the formula name instead of going to find it. See how it populates? Now average is right there. I'm going to double click it. Then I'm going to highlight my data. Click enter. The average is 69. Median equals median. Double click it. Highlight. Click enter. Median 75. And mode, remember mode, you want to highlight multiple boxes just in case. If there is more than one mode, it would populate in these other boxes below it. Equals mode. Double click mode multi. NA again, so there is no mode. All right. So as you can see briefly off of looking at these two data sets, just looking off of the center of the data, it appears that my class number 1 is performing at a higher level. Their average is 71 compared to 69 in class 2, and their median is even higher with median of 79 versus 75. All right. Now, something else that we need to look at when it comes to data analysis is we need to figure out how spread out the data is. So there's two different concepts that we use to figure out the spread of data. They are range and standard deviation. Apparently I can't type it today. Let's see. I'm gonna add these to both lists. All right. So what the range is it's your biggest value minus your smallest value. So now when you have a lot of numbers, sometimes it's kind of hard to locate what the biggest and smallest values are. So off to the side, I'm going to type in max, meaning biggest number, and min being the smallest number. Now next to max, I'm going to type in equals max, or go to formulas, more functions, statistical, max, right? And then this, once I highlight all of the numbers and click enter, will tell me my biggest number. 97 is the biggest. Equals min will tell me the smallest. Imagine if you had 1,000 numbers here. Like, come on. No one's got time for that. So the range is actually 97 minus 18. So I'm going to use Excel here. I'm going to click next to range. There's no equals range button, which is kind of bizarre. So I like to do it this way because then I can just do equals. Click on the 97 minus, click on the 18, click enter. If you're not to that level on Excel yet, then you can just go to a calculator or by hand do 97 minus 18. They'll give you 79. That is a really big range. The range is often skewed by outliers. What an outlier is it's a data point far away from the rest. It appears, I didn't do the math, but by the eyeball test, it looks like 18 is an outlier. It looks like it's a data point far away from the rest because it looks like maybe 42 is the close, no, 35 is the closest, so it's pretty far away. So the range kind of gets destroyed when there's outliers. I'm not positive if that's an outlier off the top of my head, but it looks close. Now I'm going to go over here, and I will do it for the other data set. I'm just going to copy min and max over because I'm lazy. Equals max. 97, okay. So it's the same. Oh no. Try again. 19. So it's really close. That's actually kind of crazy. All right. So range is 97 minus 19. That'll tell you how many numbers it covers, 78. That's kind of crazy. So that's interesting. Based on the ranges, which is 79 versus 78, it looks like both data sets have the same amount of spread. It looks like they're both really spread out. Now, the range is super easy and super quick. Anything that's super easy and super quick has a drawback. With range, it's accuracy. So a more accurate way to measure the spread of data is calculating the standard deviation. Now, what standard deviation means is how far is the data from the average, or how far is the data from the mean, right? So for example, if I look at this 65 right here under class 2, they are 4 below average for the class. You look at 90, they are 21 above average for the class. So you see how I'm constantly comparing each data point or each student to the average? That's what standard deviation is doing, is it's figuring out how far are you from average, and then it's basically taking all of those numbers, all those deviations, and averaging them, roughly speaking. It's not 100% exactly how it works, but it's really close. Now, you can do this out the long way. I'm just going to show you how to do it in Excel for right now. So, equals STDEV, and it's STDEV.P, because that means population. Click that, double click, highlight your data, click enter. Now to make this number a little bit easier to work with, I'm going to click on it and then use the reduce decimal button just to keep the tenths. All right, 22.7. That means majority of the people in the class fall within 22 points, 23 points of the average. So they fall either between 22, 23 below 69, all the way up to 22, 23 above 69. All right. Now let's go over to the other class. Equals STV.S or .P, sorry. Highlight, enter. Oh, holy cow. That's crazy. So they are super close. One is 22.7, one is 22.8. These data sets are super, super close. They actually didn't allow for me to make my point that I wanted to about standard deviation. And I'll make it anyways. The higher the standard deviation, the more spread out the data is. So if you look at class number 1, it's just a little bit more spread out than class number 2, 22.8 versus 22.7, right? Now, the lower the standard deviation means the less spread out they are. Now, what that also means is they're more consistent. The numbers are more consistent. So that's something to pay attention to too. If you're looking at, oh, apparently that went away. I don't know what just happened. All right, it paused out on me, so I don't know how this transition is going to look, but it's giving me 1 minute and 20 seconds to wrap this up. So, where did I leave off here? Higher standard deviation means more spread out. Lower standard deviation means more close together, which means more consistent. So for example, say you had your data and it was the success rates of surgeries for different surgeons. And one surgeon has a super small standard deviation and one has a super big standard deviation. Well, you want the one that has a super small standard deviation, assuming that their averages are roughly the same, because that means they're more consistent. So if you have two surgeons and their average success rate on a surgery is 80 for both of them, but then one has a crazy high standard deviation, meaning they're all over the board. They do surgery, some surgeries really well and some really poor. Then you got the other guy who has a low standard deviation where they're all, just a little bit above average. You probably want to go with that surgeon because there's less risk. So that's how standard deviation can play a role in all of this. All right. So that's a wrap. It says I have 20 seconds left. I hope this video helped you remember, rewind, pause, rewatch. You have all those capabilities. If you need anything else, reach out to me and I'll be glad to help. All right, take care, guys.